Are there alien lurkers in our solar system that are keeping an eye on us? Are we alone in this universe? This existential question might have come up in probably everyone's mind. Given the size of our universe and the numerous star systems it contains, it's possible that other life exists. And if that's the case, what if an advanced alien civilization that is millions of years older than we are has already discovered us? What if these aliens are present somewhere in our solar system? What if they are continually imaging us and keeping an eye on us? Is it conceivable that our solar system harbors alien life forms? We shall discuss whether an alien culture is able to observe us in this video. You must have a deep curiosity about human spaceflight and the secrets of the cosmos if you are here watching this video, so subscribe now and push the bell notification. Let's back to our potential lurkers. Enrico Fermi, a scientist, posed the query, "Where is everyone?" in 1950. The query eventually developed into the Fermi paradox, one of the most well-known paradoxes in historical times. There are countless billions of stars in our universe, and each star contains countless trillions of planets. There is a good probability of finding life given the enormous number of planets in our universe. So, assuming that's the case, spacecraft ought to be abundant throughout the cosmos. Who is present where? There is no actual solution to the Fermi dilemma, which it is. All we have are speculations, and one of those theories is that there are advanced aliens hiding in our solar system, watching us. Could we be being photographed by aliens right now as they silently observe our behavior while we go about our daily lives? This can make you shiver and make you ponder how scientifically sound this notion is. Can this truly be done? Can somebody actually watch us without attracting our attention? In order to see us, the aliens would require the technology to photograph huge distances of space. The distance between other star systems is the main obstacle to imaging them. Even the nearest stars to us look as tiny flecks of light due to their great distance. Several methods to locate and identify planets orbiting other star systems have been developed in modern astronomy. To now, we have utilized a variety of methodologies to find around 5,000 exoplanets. The ALMA Observatory captured this cutting-edge image of the young star system PDS-70 last year. The spatial resolution of the Jupiter class in this image is highly constrained, and anything smaller than that cannot be resolved by us at this time despite this technical breakthrough. Because of this, the planet similar to Jupiter likewise looks as a blur. Even if the planet's picture could be resolved at a scale of 1,000, the best we could hope for is a 1 by 1 pixel image. So, it is difficult to comprehend what kind of resolution would be needed to photograph and study a small planet like Earth. However, it is only because this planet originated lately and is extremely hot and brilliant, releasing the light that we see, that the ALMA Observatory was able to identify it. In comparison to this planet in PDS-70, our Earth is not only tiny but also noticeably faint. The only conventional answer to these two resolution and faintness issues is to construct a very large telescope. Thankfully, Gene Schneider and his colleagues analyzed the extreme limits of our technology in 2010 and found that a 70 kilometers wide telescope would be required to capture a 10 by 10 visible light image of a supersized Earth that is only 16 light years away. Now, instead of using a single telescope with a diameter of 70 kilometers, we might utilize a method called interferometry, which makes use of multiple telescopes to collect light that is dispersed over a 70 km wide area. The Event Horizon Telescope, EHT, took this concept to its logical conclusion when it notably captured the first ever image of a black hole in Messier 87 by employing telescopes all over the planet. Nevertheless, even if the entire planet served as a visible light interferometer, we still wouldn't be able to resolve exoplanets well enough to observe their inhabitants. The ultimate goal of exoplanet observation would be this. Imagine watching a video of an extraterrestrial planet in such great detail that you can clearly distinguish its strange vegetation and animals. we can observe how the planet's intelligent inhabitants go about their daily lives. Such a video may offer some very wonderful insights. Schneider determined that a telescope with the diameter of the Sun would be required to obtain this degree of detail. Nevertheless, that would merely address the resolution issue. We still want photons from those far-off exoplanets. The inhabitants of those planets would therefore be so weak that their photons wouldn't even reach us, making it nearly difficult to image them even with such a large telescope. We took the time to explain this to you because the aliens would require this technology to study us from a distance, and even that wouldn't be enough. What alternative choice is thus still available? One of the most significant telescopes for humankind, the Hubble Space Telescope, has produced breathtaking photographs of the cosmos. Hubble, which has a diameter of 2.4 meters and travels over the planet at a distance of 540 kilometers, is 75 billion times closer to the world than Proxima Centauri. The spatial resolution offered by Hubble, however, would be sufficient to view humans going about their daily lives if we turned the telescope around to look at the inhabitants of Earth. This indicates that it is possible to determine a planet's inhabitants from space, but you would likely need to travel to that star system. This takes us to the question posed in the title of this video: what if they're hiding just inside our solar system? Mission: the goal of ideas like Breakthrough Starshot is to visit and observe a far-off planet. This will be the final objective of observations, taking into consideration the capacity of our telescopes. What if an intelligent alien society is already doing this to us, given that we are curious about doing it? The idea, first put up in 1960 by Ronald Bracewell, contends that rather than listening for radio transmissions from far-off stars, we should search for probes inside our solar system. If case intelligent life arises, these Bracewell probes may have been watching Earth for millions of years. From around 2 billion years ago, the Earth has been displaying a distinct oxygen biosignature. These Bracewell probes can even use the sun's energy to collect data on us and relay it back to their home world. Notwithstanding how fantastical this concept may seem, let's examine its scientific foundation. So, it would be simple to repurpose the technologies we currently use to search for signals from faraway stars to search for similar probes and signatures within our solar system. And consider the possibility that we could listen in on the transmission being made by these covert probes. Although there may be a layer of encryption protecting these signals, the idea that they were not created for us would be exciting. We can't help but be curious about what the transmission is saying and the compression method it employs. Their language and the mathematics they employ would all be absolutely foreign to us. They need not be concerned about their privacy or encryption because all the information would be entirely foreign to us unless the aliens deliberately want us to decipher these signals and provide us with easy data forms. It would be incredible to even have such a probe in our neighborhood, which we might be able to rescue and reverse engineer. So where in our solar system will this probe be located to silently and unobtrusively study us? Where we should search for them? Let's discuss the science involved in that. This probe must be as close to the Earth as possible if it is to capture crisp, high-resolution photographs of the planet. The ideal location for that is low Earth orbit, or LEO. Nonetheless, it is already under close human observation. Over 34,000 orbiting objects, some as small as 10 centimeters in size, are recorded by U.S. space surveillance. This idea is ruled out since a probe smaller than that would be unable to understand human behavior on Earth. Our intensive monitoring of the area will put a stop to the existence of a lurker in low Earth orbit. We might then turn our attention to our moon. A probe on the moon would have absolutely steady gravity and wouldn't be affected by geological activity, atmospheric erosion, or weathering. The majority of our moon has, however, been thoroughly photographed by orbiters over the past few decades, much like low Earth orbit. With a spatial resolution of 100 meters, the Lunar Reconnaissance Orbiter captured images of the moon's surface. Hence, it is either incredibly little or we would have seen it by now if there were an alien telescope of 100 meters in size on the lunar surface. More would be required to photograph the surface of the Earth and observe its inhabitants. What remains, therefore, if the moon is out of the question? Our best hope may be co-orbital asteroids and quasi-satellites in the future. A particularly intriguing contender is Cruthen. A co-orbital asteroid measuring 2 kilometers in diameter, it travels once every 770 years in a horseshoe-shaped pattern as close to the Earth as 12 million kilometers. Even if the entire 2 kilometers of this asteroid were some kind of massive extraterrestrial telescope watching the world, it would still only be able to see a portion of the Earth's surface with a spatial resolution of no more than 4 meters, and this would only happen during these infrequent periods of closest approach. And even so, it's not enough. Cruthen is only one among a number of co-orbitals, though. What if this assortment of asteroids comes together to form an interferometric network? These co-orbital objects travel in erratic, practically chaotic orbits with respect to one another, making interferometry a nightmare. They are thought to be stable over thousands of years, but not millions. There aren't any clear or alien options or lurkers among these co-orbitals that are from another planet. Given the several severe challenges associated with unstable Earth orbits and co-orbitals, it's feasible that the lurkers would choose a more remote observation location where the Earth's gravity would not affect their probe. Yet that would require a genuinely huge space probe. For example, a telescope about the size of our moon would be needed to visually image the Earth at 1 meter resolution from a vantage point close to Saturn's distance. Of course, extraterrestrials could employ the interferometric method, but this would require scouring a much larger survey area, and the sheer faintness of these probes would make them currently undetectable. In conclusion, it is highly improbable that an unidentified extraterrestrial lurker is capable of imaging the Earth in high resolution and at visible wavelengths. Yet everything is possible. What do you think about the prospect of extraterrestrials keeping an eye on us? Would they be interested in creating such a complex system only to watch us? Let us know what you think in the comment box below. Further information regarding these extraterrestrial entities will soon be released by SETI and METI. Thus, be sure to subscribe to the channel in order to stay up to date on all the fascinating astronomy and space exploration news.